All right, good afternoon, everyone. My name is, can you hear me?
Yeah.
Okay, perfect. My name is Supratim Kundu. I'm a representative of the Georgia Institute of Technology and the VIP team from my university. The topic of today's presentation is Smart Stadium, a testbed for research, development, and deployment of sports analytics systems. So the goal of this team is to develop a testbed for using various technologies to make our university stadiums smart. And there's many sub-teams within this team, and a lot of people have been working on this. Work on this has been going on for well over a decade now. So this particular sub-team is working with video clips and official footage and annotations of plays and using accelerometer measurements and data from stands to analyze it and make sure that, and to train a model that can understand what's going on in the game, in the American football game. Whenever I say football here, I'll be referring to American football. I'm really sorry. So yeah, this team is focusing on new results from this is the ML sub team, and it's focusing on results from automated play identification and annotation. So we used two data sets as part of this process. The first one was built in-house in the Georgia Institute of Technology, where we took our GT home football games. GT is an abbreviation for Georgia Tech. These were all manually recorded from the jumbotrons in the stadium, and they were tagged with annotations also done manually. We ended up with a total of 4.7 thousand clips of football plays. After data cleaning, there had to be a lot of data cleaning because, as you can see over here, when you record stuff from the jumbotrons, you often get things like advertisements. These had to be manually deleted from the video footage, so it didn't mess with the ML model. And the second data set that we used was for the Markov chain, we used a data set from the NCAA. We obtained some XML files which contained play annotations and game statistics. And these annotated each play of Georgia Tech's 277 football games, and these were parsed to get data for about 56,500 plays. Not all of these were Georgia Tech plays, so we had to trim this down a lot. So the methods and results, the whole point of this research was to pass in video footage. So here you can see the frames for the first few seconds, let's say, of the game. These were passed to a pre-trained CNN, a convolutional neural network. And this was then passed on, the results of this were passed on to a recurrent neural network, which then output a probability vector, which contained 5 different categories: run, pass, extra point, and punt and kick. So this computer vision model just once again takes the play videos, the CNN extracts the feature vectors, and then the RNN generates the probability vector. Also, over here, you can see that we took the first 30 frames. So there's 30 images here. They were each a resolution of 224 by 224, and then the 3 represents the 3 channels RGB. So the Markov chain was trained by using the secondary data set that I just talked about, and the XML files from that. And our team generated 6 different Markov chains and compared the performance between them. The blue ones you see here are from the non-Georgia Tech games, and the orange ones you see are from the Georgia Tech games. And our team determined that the best performance was being given by the down type field position. FP stands for field position. FP distance, this stands for field position distance. And so, yeah, you can see that if you look at the performance data, the best one is down type field position. So now we have these 2 models, the first one I talked about, and then the Markov chain. We then had to find a way to put those 2 models together to obtain higher accuracy and the best possible results we could. So for this model conflation, we developed a final neural network which calculates weights from the LSTM that I talked about over here, the LSTM over here, and the Markov chain, and it put them together. And by doing so, we managed to obtain an overall accuracy of 87.2%, of which the run and pass had the runs and kicks had the highest accuracy, and especially the run. And the reason why run had the highest accuracy is because runs dominated our data set by far. We had a lot more runs than most other plays, and that's why we obtained the highest accuracy in that category. The goal is to obtain a 95% accuracy eventually, which would roughly correspond to 1 classification error per game, which would be very ideal, but work is going on that so far. Which brings me to another point, which is SensorNet data. This is another part of our research which is going on right now. What SensorNet is it's basically timestamped accelerometer data, which is collected and stored in a server. And this computes the hype of each play, which is the excitement, so to say. Sensors are put inside the Georgia Tech stadiums, which measure how much the stadium vibrates when a game is going on. And it is seen that how excited the viewers are almost always directly corresponds to how exciting the play is, like in the field. And so the vibrations measured help us keep track of that data. This hype can be integrated as another input to the ML models, as most of the plays have correspondence. Most hype plays have the correspondence with the most impactful plays. Fan play apps is another thing which our team is working on to use the SensorNet data. So one example, this is just one example of how the results from our ML model can be used in real life. So this app essentially provides users with quiz questions by taking the SensorNet data and converting it into questions based on what sort of thing was going on in the game at that point. The point of this is to keep the users engaged throughout the entire duration of the game, even if nothing special is going on at that particular moment. Let's say there's some break going on. The people running the show would ideally want the users to and the audience to be engaged even during that period of break. So this is one example of how that can be achieved and how the results from our research can be used. And also other apps are being developed alongside this, which try to achieve a similar purpose, such as Tab Drive, Friend Finder, and field goal kicking games. As for future applications, the challenge is to best fuse game video, play annotations, and fan reactions and fan input through the kinds of apps that I talked about, and by using other data sources. The hype was just one type of data, and we are also looking to expand to other types of data sources, which ultimately will enhance the fans' enjoyment of the game. Our team is continuing to collect and utilize more data sources, and we are constantly exploring more state-of-the-art architectures, deep learning architectures, which, as we all know, is a rapidly growing field at the moment. So it's very important that our team stays in touch with all the new research that's going on. Since this research originated in Georgia Tech, it's obviously being used as a testbed right now. But our team does have plans to scale our work once proof of concept is fully established to other universities and maybe even professional leagues outside of college sports. And yeah, these are the authors and the people that worked on this. Most of our advisors were master's students or PhD students or doctorates. So Dr. Edward Coyle was the lead in this research. And yeah. Thank you for watching. If you have any questions, you can come.
Any questions?
I was wondering if you can elaborate a little bit more on the use of this classification, the 5-class classification of the actions in a smart stadium. Like, what are you trying to do with it?
What are we trying?
So, I mean, the goal is to use all these components into a smarter stadium.
Yeah.
I was. I mean, I'm sorry that can't understand exactly how this is related to smart stadium. Like, how would you use it? How would you use the classification of action, which action is happening right now, whether it is a pass or play or
Right.
etc. Just want to know.
Yeah,
a
yes,
bit
no,
more.
that's a perfectly valid question. Thank you for asking. So, the entire point of this and the other models that I was discussing about, and the hype, for example, over here, the whole point of this was to ultimately get to here. Like, this is one example. The fan play app is one example of the kinds of things that you could do with this. So over here, let's just walk through it. If you collected data from the ML model, which told you what's going on in the game at this very second. This app, which produces quiz questions for the audience, this could then use that data to ask questions about what's going on exactly at this point, which would allow the user to be more engaged at that point in time. Like, yes, you could have pre-fed questions, like pre-designed questions, but those won't be as relevant to the game that's going on right now. So that won't help with getting the user to interact with the app more. So this is like,
So
all of
that
this
is
is to-
for like, people who are presently in the stadium?
yeah.
Okay.
Yeah.
Got it, thank you.
And it doesn't just have to be through the apps, it can also be through other mechanisms, just basically utilizing the data about what's going on currently in the game to keep the audience engaged.
Yeah, I guess the questions would be, should
Yeah.
be very smart questions.
Yeah,
also
yeah,
to-
exactly.
To engage.
Like this screenshot right here is currently showing how well the person is playing and how well their coach would be doing historically and everything. But this thing, it's better if you use what's going on right now. It would keep the user and the audience more engaged than it would if you just use past data, because everybody has like looked at the past data, right? So.
Right, and the current data, I guess, in that granularity would be present in the play-by-play
Yeah.
data.
Yeah.
So you would want to jump one step ahead of the play-by-play data and see next play.
Yeah.
How would that be?
Yeah.
Okay, that's very interesting.
Thank you.
Thank you.
Anybody else, any questions?
Yeah, I have a quick one. So I feel like this app is more useful for people who are, let's say, watching the broadcast live instead of those people who are in the stadium.
That could also be like, when I said audience, I also meant like also people watching from home. Like, it doesn't really matter. If you're in the stadium, like, you do contribute to the hype data that I talked about, but
Exactly.
you don't have to be in the stadium to make use of the data, of the results
That's what
from
I
it.
feel like, because people who are in the stadium, they're living the moment. They're
Yeah.
probably not checking their phone all the time.
Yeah,
Whereas people who are, in front of the TV, those are the guys who are the real, users of the app.
Yeah.
But actually, the broadcast is about 1 or 2 seconds behind the game.
Okay.
In the best broadcast, you have, so you have an advantage of being present in the stadium. So people who do betting, live betting, they use phone from the stadium to have that some seconds advantage over people who are watching it on TV.
Yeah, I have a question there. You showed the RNN, the output,
Yeah.
and the Markov, the RNN.
Yeah.
Do you have the individual scores for the RNN, the probabilities? Because you did mention the combined probability RNN and
Yeah.
Markov.
I
You don't have-
unfortunately don't, but our like the contact I showed at the end, our Dr. Call would be very happy to reproduce.
I wanted to see what's the percentage, how much more you have improved. But you have integrated with the Markov.
Yes.
Right?
Yeah.
Without it independently, what's the score? Right? How?
Okay.
Just
Yeah.
one-
Presumably it would be a fair bit lower, but I
No,
can get those results here.
Thank
Yeah.
you. Anybody else? Any questions?
Now that the EA college football game has returned, have you guys, as a team, maybe considered, I guess, like working together with them for like the hype meter or the maybe like in-game prediction changes to who might win? Something like that?
Yeah, as I said, we're always looking for new data sources and like integrating with other organizations besides just like working within Georgia Tech bounds. I mean, there's always the problems with like the data sources not being freely available and like the costs of the data sets and everything, and the cost of partnerships with other organizations. But we are definitely working towards partnering with other orgs.
Yeah, be awesome. I can see for fan engagement, I can see that a clear bridge to like the video game.
Yeah, absolutely. Like if we do manage to expand, then our user base extends like far beyond that of just people interested in games. So yeah, that's a wonderful idea.
Good luck to you guys.
Thank you.
Anybody? No. Thank you very much.
Thank you.